Okay, so here is another one. We're going to go a little bit further than the last one where we just got a picture and plotted some points. Now we're actually going to get an equation, a regression equation. So a regression equation is the line of best fit if it's linear, but we call it the curve of best fit because now you're going to be choosing other things other than just lines. So we are looking for the curve of best fit. We already know on this one here that this one's going to be a logistics function. So we already know what kind of function it is. So, but either way, what you want to do first is you want to enter the data, which I already did, and then you want to label the A and the B, so the columns to see what the names are. In this case, because we are talking about a word problem, and it's about the year, and so I'm just going to type in, instead of X and Y, I'm going to type in year, and then this one here, I am going to call it bombings because it's the number of bombings that are happening every year um, in um, in the Federal Bureau of Alcohol, Tobacco, and Firearms recorded the annual statistics on the number of bombings that have taken place in the U.S. So this is the information taken from the Cincinnati Enquirer in 1996. So this is an old one on here. And so what we're going to talk, that's the years, and then this one here is going to be the bombings. Okay, and I don't know what happened to the. And so the reason why we entered 012, even though it's the year, the first year, in order to make our calculators not work as hard, and if there's a lot of data, we don't want to use some big numbers. So the first year was 1989, and then we went up to the next one, which was 1990, and then 1991, and so on and so forth. So what it makes it easier is that the first year in 1989 is 0 year, and then this is 1 year after 1981, 1989, and then this is 2 years after 1989, 3 years after 1989, because the next ones was 89, 90, 91, 82. So the difference is going up by one. So these values should be going up by one. If it was 1989 and then 1999, then this would be 0 and this would be 10 because the difference between 89 and 99 are 10 years. So you have to look at the values that are given to you, and there should be a pattern. And if there's a pattern that's more than one, then you have to modify these values to do that. So if I wanted to find out what 1995 was, that's going to be number 6. So I could always calculate and see what values they are. So that way, this will prevent an overflow. That means that it was too big of a number, too many things to do, and your calculator can't do it. So we're going to just start off with that. The bombings and that we cannot change, because if you notice, there is no pattern there anyway. The years there was a pattern, so we could do that. If there was no pattern, then you would do both of them on there. Okay, so there we go. All right, so now we have this data. We have it labeled year and bombings on there. And so what you're going to do, and we know it's a logistics function. So again, we want to be in the first row, and we never want to be highlighting up here, leave it highlighting up there, because that'll give you an error. We want to not highlight it where we already have data, because we don't want to overwrite anything. Always put it on C or D in row 1, so that when it does calculate the information that we're looking for, we could see it because we're up there. If we're down here and highlighting down here, and then we calculate it, it'll look like we do not have anything calculated, but there really is. It just puts it everything in row 1, and then it fills it in afterwards. But if you're too far below, you're not going to be able to see it and think that nothing happened, and a lot of students do that. Okay, so now what are we going to do here? Well, we want to calculate the regression, but before we do that, we actually want to plot it, because I know it's a logistics function right now, but what if I didn't know it was a logistics function? So then you plot the points to see what type of function. So you can recognize the function and then choose the different function. It will not always be linear. It will not always be, it could be a parabola, a cubic, a square root function, a power function. It could be a logistics exponential. So we, right now, we know that this is a logistics function. So what we're going to do is then go hit menu. I'm sorry, not menu. We're going to hit control, hit escape a couple of times. Always hit, if something's not working, always hit escape a couple of times, and that should always clear it. So you do control I for insert, and we are going to insert a graph. And again, we need to plot it, but this is in function form. I don't have an equation to enter, so I wanted to plot the points. So we need to go to scatter plot form. So we go to menu, and then we go to graph edit and change it to a scatter plot form. Here, where are the X values? Well, if you called it X, the column, then you enter X. I called it year. So then it does that. And the Y values, I called that column, I called it bomb. And so that's where that column is. Now, if you entered it as X and Y, that you could enter X and Y as there. And then, of course, we hit enter. Notice again, there is nothing there. That doesn't mean something did not happen. That just means that my window, I'm only looking through this window that's 10 to the negative and positive 10 on the x's and only as high as 6. But the values that I've entered for the y values was 1600 and above. So I need to change my window so that it's that way. So we go to the menu, we go to the window setting, and I don't want you to do auto zoom. That does not help you. You need to be able to know how to modify it to get a good picture on there. And so what you want to do is you want to go to the smallest X and the biggest X on there. And so we said it was 0 and 5. So I'm going to change this because I do want some. I'm going to put in a -5 there, and I'm going to leave that at 10, and I'm going to not do the auto. I want it to be like, 1 unit is good because that's not that big. And then this one here, it's going to be 1699 is the smallest and 3100 is the biggest. That's pretty big on there. So I'm going to put down like maybe 1000, and then I'm going to make that like maybe 3500. Now, if you did 4,000, that'll work too. I mean, so you could look at it and see. Now, the distance between these two is big, so I am going to change that. And maybe, let's see how 100 is. Maybe we could do, I'm going to do 200. So let's say, okay. And so if we notice, see how there's a lot of tick marks there, we might want to change that. You could also do like 1,000, and then this case down here, each one is 1 tick mark. So you know, like, oh no, did I type this one incorrectly because it's an outlier? And so then you could always go back and check whether you did that correctly because you know around where it is, because each one tick mark is 1 point value here, but up here it's, worth 200. So you could count it and see what that value is. So scaling is really important. So make sure that you do that on your homework and on every assessment. Okay, so now I have these here. And so I know it's a logistics function. Otherwise, it sort of looks like a line there, but I already know that the data that we're talking about is a logistics function. So we're going to go back and try to get a logistics function. So you have to go back to your tables on there. And so what you're going to do is then hit menu, and then it's statistics, and we're going to do a statistics calculation. Here it gives you all the different types of regression. So we have a quadratic regression, a cubic, a linear regression. Always use this one, the mx plus b on there. Sometimes they give you varieties on there. We're going to use this one, number 3. And then the cubic regression, quartic, that's degree 4. The power regression, we're going to talk about exponential, log regression, sinusoidal regression. The sinusoidal means it's like sine and cosine on there. So the sinusoidal regression. And we're going to use, there's 2 of them for logistics. We're going to use the D one on there. And so, and that's pretty much all we're going to use. So we're going to go back here and use the D regression. And then this says here, X list. Where is my X values? Well, you could put it in the column name, and I could change this to A on there. And so that would be in column A, but I already gave it a name. So I'm going to put that in there. When column A, you need those brackets there. If you get rid of the brackets, it's going to think that it's looking for a column named A and not column A. That's the difference there. So the first one is column A, column B, column C. So it's looking for a name A. So what I'm going to do here is I am going to put in year. Maybe I don't know if it's case sensitive, but I'm just going to put that there. And then this one's going to be bomb. on there. And then I wanted to save the regression into f of 1. If you already have something in f of 1 and you don't want to do it, that's fine. You could change this to f of 2, f of 3, so you could have any of them on there and put it into any function that you want on there. F of 1 is the one that I am going to use, and then we're going to skip all the way down to where do you want the results to be. So where do you want to store them? So we put it in C or D. Remember we highlighted column C, but D is fine as well. So I am going to say okay. Notice how it has those brackets. Those have to maintain that says column D. The brackets say it's the column D. And so we hit okay. And so notice how it's in column D. It formed all the information, and notice how it started in row 1. And so this here gives you the regression of A, B, and C. So the C is the C from the logistics. It also states right here, if you want to look here, let me see if it'll do a bigger. I'm just going to scroll over. So notice on this one here, and you could see on the bottom, maybe I went too big on there. So notice down here that if I do logistics, it tells me the logistics of which function that I used. And then here is the standard form for the logistics function. C, that's the coefficient of A, and that's the opposite of B. Remember, opposite, not negative B, opposite of B, because it's going to be the opposite. And notice how A here, that's what I would put in for A. And then this one here is what I would put in for B. Notice how B is positive there, but in the equation, it's going to be negative. And because it is positive here, that means that the logistics function, I'm expecting it to go and be increasing that way. And then C is the 3,350. So that represents C that we're going to put in here. So that's how you would fill it in. So now that it calculated, we're going to go over here and say, okay, where is it? Why didn't it do it? I told it to do it and it's not there. Well, the reason is that we now have an equation, and we are still in the plotting part. So we are still in the scatter plot. So we need to go back and change it so that I could enter the equation. But I told when I was putting it in there, to enter it in f of 1. And so whenever anything is filled in and has an equation, it always goes to the next one that's empty. So I asked it for f of 1. So the next one that's empty is f of 2. So that's why it's ready there. So I have to scroll up and find f of 1. And when I scroll up and look for f of 1, there it is. There is my function. And so notice how the C is up there, how this is your A, how this is the B. B was positive, but now it's negative. And so now I am going to hit enter, and there is my regression on there. And so that's what it looks like. And what happens is that the data that it looks like, notice how it's going down that way. I'm going to change my window, and I am going to go down, because usually when we're dealing with equations, you want to know exactly where it's going to. So I'm going to go to Windows, Settings, and I am going to go all the way to I'm going to do negative 500 on there so that I could see. And it gives me some room there so that I could see what's going on here. Notice how it looks like this. This is where it's crossing. When I put in 0 into it, that's the value that I get there. And then that's what it looks like. So this is the information, and it's leveling off at 3,300. And I could give it more room up there so we could see that and see how it's leveling off on there. And we could also give it more room over here so that you could see it. So you could adjust it. So the other one is just to see the curve on there, and then we could look and see what's happening. Notice how we have some outliers on there. So it's not a perfect fit, but it's really close. It's the curve of best fit. Okay, great. I hope that made sense. All right, all is good. Oops. Okay.